Here we're asked to solve for x. So in this one here, we're talking about a domain that's all real numbers. So we're going to have an infinite number of answers because we can just keep going around the circle. So the first thing I'm going to do is I'm going to solve the answer between 0 and 2 pi. So in this case here, I'm going to solve for sine of x first. So I add 1 and divide by 2. So sine of x is equal to 1 divided by 2. And on the unit circle here, sine is 1/2 in 2 spots. And I'm estimating this circle and also not drawing a very good circle, but pretend that's a good circle. And I know that these angles here are pi over 6 and 5 pi over 6. So if we were doing a problem that said just the two answers between 0 and 2 pi, or just the answers between 0 and 2 pi, we'd be done. But in this one, we're saying like we could technically, I'm going to use a different color here, this line right here, we could do pi over 6, but then we could go all the way around the circle and do that angle as well. And then we could do all the way around the circle twice and do that angle as well, and so on and so forth. So if we're going to consider that angle plus going around the circle an infinite number of times, we can just add 2 pi times n, because we're adding 2 pi however many times that we want. So the same thing goes for the 5 pi over 6. And this is what helps us represent every solution, not just the ones within the unit circle the first time. So second one here, nope, that's C. So in this one here, again, I'm going to solve for cosine of x first. So I'm going to subtract 2 to get rid of that one, and then I'm going to divide by 2. So -2 divided by 2 is just -1. On a unit circle, the x value, or the cosine, is -1 over here, which in this case here, that is just the angle, or the radian pi. And again, I am looking for every solution, so plus 2 pi n. For C here, same idea. I'm going to solve for sine first. So I'm going to subtract square root of 2, divide by -2, which just gets me positive root 2 over 2. On a unit circle, there are 2 spots where the y value is root 2 over 2, and that is at the angle pi over 4 and 3 pi over 4. So in this one, for C, x equals pi over 4 and x equals 3 pi over 4. And because we're dealing with all real numbers, we're going to do plus 2 pi n. Last one here for D, I'm going to solve for cosine of x. So cosine x equals -3. When I look on the graph of a unit circle, here's the x value of -1. The x value of -3 is way over here, which does not actually exist. It doesn't land on our unit circle, so there's no angle that would make this equation true. So we're going to say that this one is not possible.